This video will teach you how to solve inequalities using addition or subtraction. For solving an inequality, you would do it exactly like you would an equation. Where it differs is the check step. For the check step, you want to use a number that satisfies the inequality. I'll explain what that means in a minute when I do my sample problems. And then also we graph our solution on a number line. So let's start with this first one. M plus 5 is greater than or equal to 10. If it were an equation, it would say equal to 10, and we know we subtract 5 from both sides. Exact same thing here. So I'm going to subtract 5 from both sides. And I have m is greater than or equal to 5. So I come down to my number line. I'm going to put 5, my solution, in the middle. And I'm going to skip here. 6, 7, oops, that looks bad, sorry. 5, 6, 7, 8, 9, and 3, and 1. And greater than or equal to 5. So that means that I'm going to have a filled in dot, and it's going to point to the right in the greater than direction. Now for my check step, this is what I was talking about. What I want you to do for the check step, because I know some people are having a little bit of trouble with it with equations, I want you to rewrite the equation with the variable in it, and then pick something that satisfies the inequality. What I mean by that is if you look here, you could pick 5, or you're going to pick any number larger than 5 to put in for m, and you should end up with a true statement. So if I put in 5 for m, because I have the greater than or equal to, I end up with 10 is greater than or equal to 10, which is true because it is equal. Now if I pick something larger than, because again, my solution says it's greater than or equal to 5. If I pick 10, for example, I could put 10 plus 5 is greater than or equal to 10. 10 plus 5 is 15. 15 is greater than or equal to 10. That is a true statement as well, because 15 is greater. This will throw some people off, because with equations, you're used to getting the same number on both sides, and with inequalities, that's not necessarily the case. Excuse me. So let's go over to this other problem. I have negative 10 is greater than x minus 12. This one throws some people off because the variable is over here on the right hand side. And when you look at this symbol, you would say, oh, it's greater than, so my graph's going to go this way. But it's not when the variable is on the other side. One way you could think of it is if the arrow is pointing at your variable, it's less than, and the graph is going to go this way. So this is a less than. If the big part of it, like it was the mouth you used to have in elementary school, you know, the dragon or whatever it was, is going to eat the variable, then it's a greater than, okay? So some students like to flip this because they don't like the variable on the right, but you have to be careful. If you do this, and again, this is an optional step, you take everything that's on the right and you put it on the left. But you have to flip the inequality sign if you want to do this step, okay? And again, this is optional. Optional. Flipping. You don't have to do that. Then what I would do is solve like normal. Add 12, and x is less than or equal to 2. So I come down to my number line, so 2, 4, 6, and I'm going to go down here 0, and negative 2, and it's going to be less than 2, so I'm going to have an open dot, and it's going to point in the less than direction. For my check step, I'm going to rewrite the problem as it was given to me, So my problem was given to me like this, x minus 12. And I know I have to pick a number that's less than 2, so here I cannot use 2. In this case, anytime I can use 0, and if you see 0 is one of my solutions here. That's not a negative 0, by the way. I should erase that because that looks bad. 0 is in one of my solutions, so I could use it. Anytime I can use it, I do. And this is why. So I'll put in negative 10 is greater than 0 minus 12. What happens is the 0 is just gone, and it leaves me with this negative 12. Negative 10 is greater than negative 12. Again, a true statement, and it works. let's move on. Here I have two more samples. I have the y plus 4 on the right side. This time I'm going to leave it on the right side because I don't want to flip it over there. I'm going to subtract 4 from both sides. And we get y is less than or equal to 6. When I come down here, my graph is 6, 8, 10, 4, 2. Now it's greater than or equal to, which means I need a closed dot, and it's going to point. Oh, whoa, I just made a mistake myself there, didn't I? I looked at that and I said that's a greater than or equal to, and it's not. That is less than because it's pointing at my variable. See that? Even I can make that mistake. You got to be careful with that one. And then what you want to do is come over, do your check step, and you want to rewrite the equation or the inequality as it was given to you, and then pick a number that satisfies the inequality. So I said y could be 6 or it could be anything smaller. Again, I like, if I could use 0, I love to use 0, and I can here. And what I end up with is 10 is greater than or equal to 4. And it works. That's a true statement. Now, the next one, x plus 2 is greater than negative 3. Subtract 2 from both sides. And x is greater than a negative 5, because it's a negative 3 and a negative 2 give you negative 5. So for my graph, only my numbers down here, I have negative 5 here. Then I'll make this negative 3, negative 1, negative 7, and negative 9. And x is going to be greater than, which means it's going to be an open dot, and it's going to point to the right. For my check step, I'm going to use, whoa, that pen's a little too thin for me. I'm going to use the original equation, and I'm going to substitute the variable with something that satisfies the inequality. Now if you look, 0 is in my solutions. It'll be right there. So I'm going to put that in. 0 plus 2 is greater than negative 3. You don't have to, okay? You just have to pick one that's actually one of the solutions. And use your graph to help you with that. So the 0 is gone, and 2 is greater than negative 3. That's a true statement. All right, here are two more. I want you to try these yourself. So go ahead and pause the video and try these two problems. Okay, for this one, subtract 4 from both sides. And x is greater than 0. My number line, 0, 2, 4, negative 2, negative 4. For my check, I need, x plus 4 is greater than 4. I need to pick something larger than 0. Let me do my graph real quick when I'm thinking about it. So it's going to be open, and it's going to point to the right. And I need something that is larger than 0. So I'll put 2 in there. 2 plus 4 should be greater than 6. 4. 6 is greater than 4, and it works. Doing the math in my head and it's coming out my mouth. Sorry. All right, next one. I want to add 9 to both sides. And this is one that's tricky again because the variable's on the other side. And I have x is less than or equal to 10. So when I graph that one, and here let me do my numbers first. 10, 12, 14, 8, 6. And it's going to be a less than or equal to, which means I will fill it in, and it's going to point to the left. And again, because it's pointing to my variable, it is a less than. For my check step, I'm going to rewrite the original inequality that was given to me, and I'm going to substitute it with one of the solutions. Now here, 0 will work. So I have, sorry, 1 is greater than or equal to 0 minus 9. 1 is greater than or equal to a negative 9. And that is a true statement. All right, last two problems. Go ahead and pause the video and do these as well. And then you are well on your way to solving many more interesting inequalities. Okay, this one, subtract 4 from both sides. And we have x is less than -1. So here I have -1, and here would have 0. This would be a +1, and this would be a 3, and this would be a -3. This would be a -5. There. And it is, excuse me, less than. So that means it's not included, and it's going to point to the left. For my check step, I'm going to use the original inequality. X plus 4 is less than 3. I'm going to pick something that would satisfy it. Now here I can't use 0. So what am I going to use? Well, I can use a -4 because that would be right here. It's in my solution, and that would make the math real easy to do here. -4 plus 4, which we know is going to be 0. And 0 is less than 3, which is a true statement. So if you can't use 0, then I would try and pick something to make the math easy. All right, next one, we have a +3, so we want to subtract 3 from both sides. X is greater than 4. So down here, I'm going to put 4, 6, 8, 2, and 0. And it's greater than, so it's going to be open and pointing to the right. And then my check step, pick something that satisfies the inequality, but first I'm going to write the original inequality as it was given to me. And it has to be larger than 4. So when I look at that, well, what would make the math really easy here? Well, 7 would. 7 plus 3 is 10. That was a 3. And then 10 is greater than 7, and it works. Okay? That's all. You have a good day. Goodbye.